Okay, so today I'm going to show you the steps in modeling this part. And so we're going to go through the steps step by step how to model this. Notice that I'm using Solidworks 2017, so the screens may look a little bit different, but overall the procedure should be the same. So I'm going to go File, New, I'm going to select Part, click OK. And now I'm in my part environment. I have my three principal planes, my origin, which is at the intersection point of those three planes. And to start this, I need to select a plane to create a two-dimensional sketch on. So now I'm sketching on that top plane. I'm going to click my circle tool to start this, and I'm going to draw a circle. And then I'm going to draw a rectangle snapping from the top here down to the bottom. And then I'm going to use the power trim. I really like this power trim because if you click and you got this little, the snake everywhere the snake bites, you get it trims it. So now this sketch is blue, I want to make this black, so I need to start adding dimensions to this. So let's make this a radius of 1.5. I'm going to make sure I'm in ISO. Let's change this to ANSI. Click OK. Good, so I got my 1.5 there, and you see that some things started to turn black, but down here I'm missing a tangent relation. Now that makes that black, but this is still underdefined because the overall length of the part is not defined. So I'm going to go from my origin to this length, and looking at my drawing, that is 4.5 called out in that area right there. Okay, so the next step is I am going to draw a circle from the midpoint here, circle tool from the midpoint coming up. I'm going to use my power trim again, and now I need to define this circle. So one thing, I want to select the center point of my circle and this top line right here, and I'm going to make those coincident. That constrains this center point so that this is a 180-degree arc length. Let's put a dimension on this, which is a 0.625 radius. And then the last thing you got to do is you got to constrain this up and down, right? Because this is sliding around. So I could easily select the center point and my origin and say that those two should be horizontal to one another, and now I have this fully defined sketch. Once you have a closed shape, fully defined sketch, you can then go to Features, Extrude Boss Base, and I'm going to extrude this the full length of the part, which is 2 inches. Okay, so the next step is I'm going to select this side plane to model on. I'm going to create sketch. So now I'm sketching on this side plane. And if I want to look normal to that surface, I can click this button and go the normal to. That brings me in where I'm looking exactly at the surface I'm sketching at. I'm going to draw this rectangle down here. And notice that I snapped from this visible line down to this edge of the part. And so I have these coincident constraints that allow these top surfaces, these top inside lines to be fully defined right off the bat. So now all I need to do is define the length of this line, which is 3, and the length of this line, whoop, the drawing calls it out from this bottom down to this bottom surface is 1.25. So again, the dimensions that I just input are this one and this one. You want to always try to use the dimensions from the problem when you're modeling. It's a good practice. I'm going to put the fillet in the sketch because I like to add fillets to the sketch. So my radius of my fillet is 0.250. Entities to fillet, I'm going to click here, select this point, click the check. Now that I have this, I can kind of twirl it a little bit. I'm going to go Features, exit my fillet first, Features, Extrude Cut. And I don't want to do a blind extrude. I don't want to stop my extrude. I want to go all the way through the part. So I'm going to come up here and I'm going to say direction 1. I'm going to go through all. Click the check, and you're done. Okay, so now the next step is I'm going to select that same surface, and I'm going to go Sketch, Sketch, and I'm going to select draw another rectangle on that surface. Let's go in and look normal to that surface so we can kind of see exactly where that rectangle is. Smart dimension, and this height of this rectangle, oops, I'll leave that there for now. Height is 0.750. From the bottom to this surface is 0.625. From this surface up to this surface is 0.75. Okay, so you notice that this first dimension I put 2.87 is I like numbers found in nature, so let's make that 3. The idea is that you want to extend this rectangle past the visible surface of this so that when you cut, it's going to go all the way through. Now that we have that sketch fully defined, closed shape, we can go Features, Extrude Cut. Instead of blind, let's go through all, hit the check, and we're good. Okay, the next step. I'm going to select this top surface, and I'm going to, let's look normal to that top surface, and I'm going to click Sketch, Sketch, and I'm sketching on this blue surface right here. I'm going to snap to my origin, and I'm going to position this hole, attach to the origin, and then give it a dimension of 1 inch diameter. That's a diameter symbol. Be sure not to mix up your diameter and radii. Once you have that, I'm going to go Features, Extrude Cut, and I'm going to go, instead of blind, through all, because I want to take this extrude cut all the way through the part. Click the check. Now we're almost done with this feature. There's one more thing we need to add, and that thing is a hole. We need to add a counterbore hole in the part. This is the counterbore hole we're trying to add right there. So doing so, we're going to use something called the hole wizard. So if you go hole wizard, okay, so here we have all these different options for holes. We have a counterbore hole, which is what we want to select, a countersunk hole, a blind hole, a straight tapped hole, tapered tapped hole, a legacy hole, which is like a custom type of hole, and we have these different slot options here that you can see. So we want to do a counterbore hole. Yeah, it's fine, whatever. And this is set up to where you could select a certain type of fastener, and then it will automatically give you the counterbore dimensions you need given the size of said fastener. So we know exactly what dimensions this needs to be. So what I'm going to do is I'm just going to not select anything up here. I'm just going to go Show Custom Sizing, and I'm going to type in the numbers that I want here. So this is a 0.5 for the through hole, the counterbore diameter is 0.875, and the counterbore depth is, whoop, oh geez, go back here. Counterbore depth is 0.250, okay? In condition, I'm going to go through all because I know I want that hole to go all the way through my part, and I'm going to make sure that none of these options are checked because I just want a simple counterbore hole. The next step is you click Positions, and it says select a face for the hole or slot position. So I want to select that face. And now you notice that my next option is it's giving me a preview, and I can drop that point, and then it's going to give me a preview for a secondary hole if I wanted to add 2 holes on that surface. I don't, so I'm going to press Escape. And then this hole is floating in space. I can drag it around. This is a 2-dimensional sketch, and that sketch point is blue, meaning it's undefined. So I'm going to take my smart dimension, and I'm going to dimension according to my print. This is 1.750. This is 1.50. And I'm going to twirl it around, kind of see what I'm doing. That looks about right. Hit the check, and we are good. So that concludes this demonstration. We have 1, 2, 3, 4, 5 features. I can expand each feature and see that every sketch is fully defined. There's no minus sign. Remember, minus sign means minus points. I'm going to patent that. That's a good one. And yeah, we're done. Thank you.